Hello and a warm welcome to the AI with Arun show. Imagine you are the CEO of a major tech company. You have designed the most powerful computer chip ever. It has hundreds of billions of transistors, but you hit a terrifying bottleneck. You can't actually build it because the process of creating the blueprints is too slow. It takes 30 million CPU hours for one tiny step, dragging the launch out for months. This is not just a sci fi movie. This is the reality of the semiconductor industry today. We have reached the physical limits of Moore's law because our tools are too slow. That is why on December 1st, 2025, NVIDIA made a massive strategic move. They executed a $2 billion equity investment in Synopsis, the world leader in chip design software. This is not just a partnership, it's a calculated vertical integration that will blur the lines between hardware, NVIDIA, and software, Synopsis, fundamentally changing how every chip for every AI is designed and manufactured. To understand the deal, you need to understand electronic design automation or EDA. Think of EDA as the software that translates a brilliant idea for a chip into the physical map needed for the factory. It provides the software utility to turn logic into physical transistor layouts. For decades, this software was the domain of two giants, Synopsys and Cadence. But the world has changed. Chip complexity has exploded. We are shrinking features down to the angstrom scale, 2 nanometers and beyond, and trying to cram hundreds of billions of transistors into one device. The traditional way of running the software, using slow general purpose CPU servers, has become the major bottleneck in the supply chain. If you need a whole farm of servers to compute a single mask set over weeks, your ability to innovate grinds to a halt. We need a paradigm shift. And NVIDIA believes the answer is moving from general purpose computing to accelerated computing, meaning their GPUs. So, what exactly did NVIDIA buy? They acquired about 4.8 million shares of Synopsys in a private deal valued at over $414.79 per share. Now, this is a rare and powerful move. $2 billion direct equity stake in a partner that is both a key customer and a key supplier. We call this a circular economy of innovation. Think of it this way: NVIDIA gives Synopsys $2 billion. Synopsys then uses that capital to accelerate their AI tools, which requires buying massive amounts of NVIDIA's latest H100 or Blackwell GPUs. In turn, NVIDIA relies on Synopsys software to design those very same next gen GPUs. It's a closed virtuous loop. This move immediately elevated Synopsys as the first among equals partner. The market immediately recognized us, sending Synopsys stock soaring 7 to 8%. The deal isn't just about money, it's about a complete re architecture of the industry. The alliance is focused on four major strategic areas or pillars designed to make engineering exponentially faster and more autonomous. The first pillar is the physics of acceleration. We need to overcome physical manufacturing bottlenecks using GPU power. This means solving the printing problem. Pillar number two: accelerated EDA stack. We need to use GPUs to speed up all the design software, not just one part. Pillar number three: agentic AI engineering. We need to stop relying on just human engineers and empower autonomous AI agents. This solves the talent problem. And pillar number four: industrial metaverse. We need to create the perfect digital twins of everything: the chips, the servers, and the factories to catch errors before they cost billions. So let's start with pillar number one, which is the physics problem. To make chips, you use a process called lithography, which is like using a massive high tech printer to stamp patterns onto silicon wafers. The light used in this process has a wavelength that is larger than the features we are trying to print, like trying to paint a microscopic line with a paintbrush that is too thick. To fix this, the industry uses complex mathematical tricks called optical proximity correction, OPC, and inverse lithography technology, ILT, to purposely distort the mask pattern so the resulting print is correct. And that's where the slowdown happens. Simulating the physics of light through glass and silicon consumes billions of CPU hours every year and is the primary bottleneck for the entire supply chain. This process currently takes weeks with traditional server farms. The solution, co-developed by NVIDIA, Synopsys, TSMC, and ASML, is called QLitho. QLitho is a software library that takes those complex lithography algorithms and ports them directly to the massively parallel architecture of the GPU. Why GPUs? Because the math needed for these physics simulations involves heavy matrix and pixel calculations, which is exactly what GPUs are designed for. The result is staggering. QLitho delivers a 40 to 60x performance improvement over the traditional CPU workflow. Imagine consolidating your data center. A small rack of only 500 NVIDIA Hopper GPUs can replace a massive sprawling farm of 40,000 CPU servers. This drops the processing time for a single mask set from about 2 weeks down to overnight. Just think about the value over 8 to 12 hours from 2 weeks. NVIDIA's $2 billion ensuring that Synopsys aggressively integrates QLitho into its market leading tool, Proteus. Synopsys projects that Proteus will accelerate simulations by up to 20x using the latest Blackwell architecture. But here's the true strategic genius. This creates a defensive mode for NVIDIA. If the entire manufacturing supply chain, TSMC, the foundry, ASML, the machine maker, and Synopsys, the software, all standardize on the NVIDIA CUDA accelerated QLitho platform, it means all the manufacturing tools run best or only on NVIDIA GPUs. This effectively locks in the manufacturing layer of the semiconductor industry to the NVIDIA ecosystem. It becomes incredibly difficult for any competitor like AMD or Intel to displace NVIDIA hardware from the factories that build the world's most advanced chips. Pillar 2 focuses on making the rest of the design software, everything from laying out the wires to simulating power, just as fast as the lithography step. Historically, chip design software tools like placement and routing were not very parallel. They were bound to the slow CPU performance. The NVIDIA investment is funding the complex job of refactoring Synopsys core design engines to use specialized CUDA-X libraries. This means taking old, slow code and making it speak the language of the GPU. We are seeing massive acceleration across the board. PrimeSim is a tool that simulates electrical circuits. By using the new NVIDIA Grace Blackwell superchip, it runs up to 30x faster. Even for material science, like modeling new materials for the tiny 2nm transistors, Synopsys Quantum ATK can accelerate results by 100x. The story gets even bigger when you consider another recent Synopsys move, their acquisition of Ansys. Ansys is the world leader in multi-physics simulation, tools that model things like heat, airflow, and mechanical stress. By combining Synopsys, the electronics expert, and Ansys, the physics expert, they create one powerful platform. And guess what is the glue that holds these massive physics and electronics simulations together? You guessed it right, NVIDIA's accelerated hardware. Take Ansys Fluent, a fluid dynamics simulator. When running on NVIDIA GH200 superchips, it shows a speed up of 110x, 500x compared to CPUs. This allows engineers to perform thermal aware chip design in real time. They can simulate how heat will dissipate from a complex chip through the cooling system of an entire server rack before they even build a physical prototype, dramatically reducing the risk of failure. Now we move to pillar 3, which is the talent problem. The industry faces a severe shortage of engineers experienced enough to design these complex AI chips. Making tools 40 times faster does not help if you don't have enough people to run them. Our first wave of AI in chip design involved copilots, tools like Synopsys.ai Copilot that offer suggestions to human engineers, giving a nice 30 to 40% productivity boost. But the $2 billion investment is underwriting the radical shift to agentic AI. Think of an AI agent not as a helpful assistant, but as an autonomous, goal oriented engineer. It can work alone to achieve a complex goal. So, how does an agentic AI engineer work? It follows 3 steps. First is reasoning. You give it a high level goal like close timing on this block while reducing power consumption by 10%. In the planning phase, the agent breaks that huge goal into hundreds of smaller steps: floor planning, synthesis, routing, optimization. The third one is execution. The agent takes control of the underlying Synopsys tools and performs all the tasks without human intervention. It learns and optimizes as it goes. NVIDIA provides the brain for the system through the NVIDIA Agentic AI stack, which uses highly customized large language models trained specifically on chip design data like Verilog. The impact is already proven. Early tests of Synopsys chip design agents showed a 72% boost in productivity in formal verification flows. This technology is a force multiplier that allows the industry to keep pace with the exponential growth of complexity. Our final pillar addresses the massive cost of manufacturing. Building a modern factory or a fab costs over $20 billion. An error in layout can cost millions per day. The solution is the industrial metaverse that uses NVIDIA Omniverse to create digital twins, perfect physically accurate virtual replicas of factory, assembly lines, and server racks. An example is TSMC, the world's leading manufacturer using Omniverse and Synopsis tools to simulate intricate piping systems inside their fabs. This allows them to resolve layout issues and collisions in days, not months, saving millions in construction costs. You can build a digital twin of an entire NVIDIA GB200 NVL72 rack. You simulate the airflow and the power delivery of the entire system before you build the physical hardware, which drastically reduces the risk of expensive hardware failure down the line. This is the ultimate form of risk mitigation, blending design from Synopsys, physics from ANSYS, and visualization from NVIDIA Omniverse into one cloud-ready simulation platform. The chip design software market has long been a stable duopoly between Synopsys and Cadence Design Systems. The $2 billion investment fundamentally changes that dynamic. Cadence is still a strong player. They also use NVIDIA hardware running their own supercomputers, like the Millennium M2000 on Blackwell GPUs. However, the $2 billion stake gives Synopsys what analysts call the NVIDIA halo effect. It's a vote of confidence that Synopsys is the preferred software layer. The risk for Cadence is this: NVIDIA might give Synopsys earlier access to hardware prototypes, software optimizations, or driver updates, what we call day zero support, potentially giving Synopsys a permanent performance edge over Cadence tools. Why is NVIDIA spending $2 billion to make chip design cheaper? The answer lies in an economic theory called the Jevons paradox. This paradox states that when you increase the efficiency of a resource, you don't necessarily decrease its use. Instead, you increase the total consumption of that resource. The resource here is the chip design compute. The efficiency is talking about is NVIDIA and Synopsys making designing a chip 40x faster and cheaper. And the result, the market won't spend less money on design. They will simply design exponentially more chips. This efficiency democratizes chip design, encouraging new players like automotive companies or cloud providers to build custom chips. Every single new chip project requires massive simulations. And since all the tools are optimized for NVIDIA, every new project translates directly into sales of NVIDIA hardware. This creates a virtuous, self-healing demand spiral for NVIDIA. To conclude, the NVIDIA Synopsys investment is a masterstroke. It's an acknowledgement that human engineering alone can no longer handle the complexity of the AI era. The solution is the fusion of hardware and software, where the designer and the computer are one. The alliance delivers a tripartite revolution: the physical revolution from Litho, the workforce revolution with agentic AI, the system revolution with digital twins. The partnership is like giving a brilliant architect the ultimate cell-building tools. This move doesn't just accelerate chip design, it locks NVIDIA as the undisputed engine of the AI economy for decades to come. With that, we come to the end of the show. Please support our work by joining us as a member. All you have to do is go to the bottom of the description and you'll see the link on how to become a member. And if you learned anything in this video, please like, share, and subscribe to the AI with Arun show. Thank you so much for watching.